Yes, you are most welcome to yet another episode of Trigonometry for advanced level mathematics. My name and telephone contact are shared on the screen. You can also follow this channel, subscribe to it, and also be a part of our discussion. Today we're going to look at trigonometric equations. In the previous episode, we have already seen how to solve trigonometric equations using T formulae and using the r cos r sine form, what we generally call the harmonic form. Now, for today's lesson of trigonometric equations, in this episode, we are looking at general equations which may not have an explicit method of solving, but each equation can be solved using the principles that we have learned in all the previous episodes. So I won't have a general approach to a given question, but we shall do questions as they arise. Each question might have its own way how it can be handled. Let's go straight to examples, and we begin with example 1. I'm going to be a bit speedy. In other words, you can be following with your calculator and your paper and notebook and a pen. You pause and fill in the missing steps as we proceed. Question number 1 says solve cos 2x plus sin squared x is equal to 1 for angles ranging from 0 degrees to 360 degrees. Now here for us to solve, there are two ways of doing this, because we must first change these angles to the same. If it is 2x, we also have a 2x this side. If it is x, we also have an x this side. So any of the two. Either you change the x to 2x or you change the 2x to x. That you can proceed solving that. I'm going to start with the method 1, where I will change the 2x to x. Cos 2x is the same as 1 minus 2 sin squared x, because they must be similar. 1 minus 2 sin squared x. It's what I have chosen to use because it is similar to what I already have. Sin squared x is equal to 1. Now this 1 will go with this 1. I'll remain with the negative sin squared x is equal to 0, which means sin squared x is equal to 0, which means if I take a square root on both sides, I will have sin x being equal to 0. So x is sine inverse of 0, and sine inverse of 0 is 0 using our calculator. So we also know that sine 0 is 0. Now if you take it to be acute, then sine is positive. If we take the positive value, sine will be positive in the second quadrant. 180 minus 0. Again we get 180 minus 0. We also get 180. Even if we took 0 as negative, 0 is neutral. But even if we take it to be negative, again cosine, sine is negative in the third quadrant. 180 plus 0 is still 180. Then in the fourth quadrant, sine is negative. So if we take 0 now to be negative, since it is neutral, we can have 360 take away 0, which is still 360 degrees. That is method 1. In method 2, we can actually change the sine squared x into cos 2x, or we can say now cos 2x. Now sine squared x in terms of cos 2x, if you still recall what we applied under multiple angles. We had cos 2x being 1 minus 2 sine squared x, but now we want to make sine squared subject, so it will be a half into 1 minus cos of 2x. This should give us a 1. Please, you can pause and verify that what we've applied there. We multiply through by 2, we get 2 cos 2x plus 1 minus cos 2x is equal to 2. Collecting our like terms together, this and this will give us negative cos 2x. Then I think it is a positive cos 2x. Then 1 goes the other side to get us a 1. So cos 2x is equal to 1. So what is 2x? 2x is cos inverse. 2x is cos inverse of 1. Now the cos inverse of 1, remember our angle is between 0 and 360. But now we have 2x, which means 2x will be between 0 and 720. Now cos inverse of 1 is 0. That is in the first quadrant. But again, cos is positive in the fourth quadrant. Cos is positive in the fourth quadrant. So it will be 360 minus 0. We get 360 degrees in the fourth quadrant. Then we now come back for the second round to make it 720. When I add 0 on 360, I get 360. So I can't repeat it. When I add 360 on 360, I get 720 degrees. Now to get x, I will divide all sides by 2. So 0 divided by 2 is 0. 360 divided by 2, 180. Then 720 divided by 2 is 360 degrees. So we again end up with the same answers as we got using method 1. Let's go to question number 2. Question number 2 says 2 cos squared theta minus 3 sine 2 theta minus 2 is equal to 0. Now here we have a 2 theta and a theta. So these things must be taken to something common. So we're going to begin with the first approach. Now in the first approach, we're supposed to change this cos squared theta to cos 2 theta. This one will be 2 cos squared, because we know that cos 2 theta is 2 cos squared theta minus 1. So if I want this one only, it becomes cos 2 theta plus 1. So cos 2 theta plus 1. Now minus 3 sine 2 theta is equal to 2. There are some things which are common. I will have, like this 1 and the 2, I will have cos 2 theta minus 3 sine 2 theta should give me positive 1 when 1 goes to the right hand side. Now at this stage, we are back to what we know. From here, we can proceed by approach 1. Method 1, you can let t to be tan theta. Then you put t formula. 1 minus t squared over 1 plus t squared. That is using the t formula. minus 3 times 2 of times 2t over 1 minus plus t squared is equal to 1. When you reorganize this, you'll get 2t squared plus 6t is equal to 0. Now you proceed to get the values of t and you work that one out. I'm leaving it to you because we have already seen use of the t formulae in the previous episodes. Now, what about method 2? For method 2, from this stage here, we can now bring in the other form. So where you have, since we have a minus here between the two, we can see that we can use cos plus. You can say let cos 2 theta minus 3 sin 2 theta be equal to r cos of what? Of 2 theta plus beta. Then from here, you know how we are proceeding. We would open the brackets, compare coefficients of cos 2 theta, coefficients of sin 2 theta, find the value of r, find the value of 2 theta, and proceed with that solution. Maybe you'll allow me to do this one because I'm seeing there is a trick of the 2 theta there. It may be difficult for us to edit the range. Allow me this to finish up this one just for the sake of that 2 theta plus beta. Let's open the right hand side. R cos 2 theta sin beta. This cos again, sorry. Cos beta minus r sin 2 theta sin beta. Then we compare. You know what to compare there. Compare coefficients of cos 2 theta, compare coefficients of sin 2 theta. Revisit our last episodes to get what we used to do there. In the interest of time, we shall get r as root 10. Then we get beta as 71.6 degrees. So therefore, in our original question, in our step where we began to introduce this, we can replace the left-hand side, the whole of this side here, we can replace it with root 10 cos of that. So we shall have, therefore, root 10 cos of 2 theta plus 71.6 degrees is equal to 1. Now we shall have cos of 2. Please make sure that you watch these videos in their order so that you can be able to always find yourself when we refer to the previous episodes. Is 1 over root of 10, which means 2 theta plus 71.6 degrees is cos inverse of 1 over root 10. That's why I picked interest in this question. It is because of this range here. Now, in our question, which was asking us to find the theta, they were asking us to find angles in the range 0 degrees to 360 degrees. But now there has been a change here, which means 0, where there is 0 degrees, we shall say 0 times 2 plus 71.6. So we're dealing with 71.6 degrees less or equal to 2 theta plus 71.6 degrees, then less than or equal to. Now, in the place of 360, we shall multiply 360 times 2, we get 760 720. We add there 71.6 and we get 791.6 as our upper limit. So we shall first find all angles in this range. So we begin. Cos is positive. Cos is positive in the first quadrant. So we look for cos inverse of 1 over root 10. Cos inverse of 1 over root 10. Itself, the first angle we get there is actually 71.6. You'll be using your calculators there. Then we also look for the second quadrant where cos is positive in the fourth quadrant, which is 360 minus 71.6, and it gives us 288.4. Then the other angle we have, now these ones are between 0 and 360. Now to go for another round, because you have to go up to 720, so it means after 791.6, so I have to go for another round. Now another round is got by these first angles we have got in the first quadrant. We add there 360. So 71.6 degrees plus 360, we shall get 431.6. Then this angle plus 360 degrees, we shall have 648.4. Now from here, again, we go to another circle by adding here 360 and adding here 360. But when we do it here, when we add 360 here, what we get will be 360 plus here, we shall get 791.6. 791.6. Excuse me. If we go again to add 360 on this one, 360 degrees, it will take us to 791.6 as our next angle, and so on and so forth. Now, let us, of course, now it will be pushing us outside our range. Now, to get the value of theta, it is like making theta subject from this expression. So we shall be saying 71.6, take away this, divide by 2. That one will give us 0. Then we go to 288.4, take away 71.6, divide by 2. That one will give us 108.4. We shall go to 41.6 minus 71.6, you remain with the 360, divided by 2, we get 180 degrees. We got the last one, 648.4, take away 71.6, divide by 2, I end up getting 288.4 degrees. So those are all the solutions for the given angle range. Can now go to question number 3. Question number 3. Question number 3 says solve sin x plus sin 2x, plus sin 3x is equal to sin 2x plus sin 4x in the range 0 to 360 degrees. So we shall begin from the left hand side here. Sin 3x plus sin x. Here you have nothing to do than apply what we have already seen before. You shall have nothing else but apply factor formula. Now sin 3x plus sin x is 2. I told you always begin with a bigger angle. 4x over 2 is 2x. 3x take away x is 2x divided by 2, you get x. On the right, you'll have also 2 sin cos, starting with a bigger angle. 4 plus 2, 6. 6 divided by 2, 3. Then cos. 4 minus 2, 2 divided by 2, 1. Now, please don't cancel out the cos x. The cos is on both sides. No, because it is the unknown. We can't divide through by it. So what we do is the 2 can be divided through. But here we just collect like terms. Shall say cos x into sin 3x minus sin 2x is equal to 0. So cos x. Now here in brackets we shall have 2 cos 3 plus 2, 5. 5 divided by 2, 5x over 2. Then sin 3x minus 2x is x divided by 2 is x over 2. This is equal to 0. So in the end we have cos x. That's 2, you divide through by 2, it goes. Then sin x over 2 is equal to 0. Now each of these brackets can be equal to 0, beginning with cos x. Cos x is equal to 0. X is cos inverse of 0. Between 0 and 360, where is cosine 0? Cos is 0 for 90. Cos inverse of 0? No. Yes, cos inverse of 0 is 90 degrees. That's our first angle. Then we have 270. How do we get it? If you assume 0 as positive, that's 90 is in the first. In the fourth, 360 minus 90 is 270. If you take it as a positive, as a negative value, the principal is 90. Second quadrant cos is negative. 180 minus 90 still you get 90. In the third quadrant, 180 plus 90 gets 270. So whether you treat 0 as positive or as negative, it will always give you the correct results because it is neutral. Now let us look at cos 5x over 2 is equal to 0. So 5x over 2 is cos inverse of 0. Now here comes the range issue. Our range was 0 to 360. So if I have 5x over 2, so I should do the same thing on the range. Multiply by 5, then divide by 2. Now our range will change for the value of that one. If you do that one for 0, 0 remains 0. Yeah, 0. 360. 360 times 5, then divide by 2. It means we are stopping at 900. It means we shall go as many quadrants as possible, as many cycles as possible until we reach the limit. Now, cos inverse of 0 is 9. That is the first arm. Then 270. We have already seen 270 in the first cycle. Now, going for the next cycle, I said we keep adding 360 on each of them. So 90 plus 360, you get 450. This 270 plus 360, you get 630. We are still less than 900. So we now go to another quadrant. Now, if you want to go to another cycle would be the third cycle. Now, the first two cycles are 720. Now, 720 plus 90, we get 810. Let's now try the next one. 270 plus 720, you're above 900. So you're stopping at 810. Now, to get the value of x, each angle here you will multiply by 2, divide by 5. You're making x subject. So if you do it to 90, you get 36. That is saying 5x over 2 is equal to 90. Find x. So x is 36. Then 108 degrees for this one. 450 gives you 180 degrees. 630 gives us 252 degrees. I10 gives us 324 degrees. So therefore, what is our x generally? Collectively, our x is 36 degrees. The smallest, followed by 90, followed by 108, followed by 180 degrees, followed by 252 degrees, followed by 270 degrees, followed by 324 degrees. That is a set of all solutions for that. Now, let's go to question number 4. Question number 4 says solve tan 2 theta tan 4 theta is equal to 1. Again, here we have to struggle to make them have the same angle. So 2 theta and 4 theta, we can easily turn 4 theta to 2 theta. So tan 2 theta, now 4 theta is the same as 2 tan 2 theta out of 1, this one comes from multiple angles. 1 minus tan squared 2 theta is equal to 1. We shall get 2 tan squared 2 theta over 1 minus tan squared 2 theta is equal to 1. Now when you rearrange this thing, you get tan squared 2 theta. You will get tan squared 2 theta. Try to simplify. Tan squared 2 theta is equal to a third, which means tan 2 theta is got by applying on both sides a square root. It gives us plus or minus 1 over root 3. Now when tan 2 theta is equal to positive 1 over root 3, so 2 theta is tan inverse of 1 over root 3. Where is tan positive? Again, remember that even here we are dealing with the 2 theta, which means for us we shall move from 0 to 720 for 2 theta because the theta was stopping at 360. So tan inverse of 1 over root 3, this is supposed to be 30 degrees. The calculator, the degrees. Where again is tan positive in the third, 180 plus 30 is 210. But we want to go for 2 cycles with 720. We add here 360, we get 390. And we add here 360, we get 570. which means our theta in this case is 15 degrees, 105 degrees, 390 divided by 2. The 150 plus 45 shall have 195 degrees. 5 divided by 2 will give us 285 degrees. Then when tan 2 theta is negative 1 over root 3, 2 theta is tan inverse of negative 1 over root 3. That should be theta principal angle tan inverse of 1 over root 3. But now negative is in the second quadrant, which is 108 minus 30, which is 150. Then in the fourth quadrant, 360 minus 30, we get 330 degrees. Then we again go over for the second cycle. 360 plus 150, we get 510. Then 360 plus 330, we get 690. Which means theta, in this case, divided by 2, you'll get 75. You'll get, you have 75, you have to divide by 2, you get 165. 165 degrees. 510 divided by 2, you get 255. 690 divided by 2, we shall get 345. So the combined solution is combining these solutions and the other ones into one set of 8 solutions. Preferably, you arrange them in ascending order, starting with the smallest or the least. Let's go to question number 5. It will be our last one. Question number 5. We have 3 tan squared x minus 5 sec x plus 1 is equal to 0. Now, but this time they want it to be in the range from 0 to 180 only. So we are looking for only answers in the first 2 quadrants. Now 3 tan squared x minus 5 sec x. But we preferably here, the trick is now to change everything to either sec x or tan x. But if you are thinking tan x, we shall have square roots which will disturb us. So my advice would be change to sec. So if I change to sec, I will have 3. Now tan squared x is the same as sec squared x minus 1. Then minus 5 sec x plus 1 is equal to 0. When you simplify everything there, you will get 3 sec squared x minus 5 sec x minus 2 is equal to 0. When you solve this expression, or when you factorize fully, you will get, either you factorize or use the formula method, but you will get sec x, you will get sec x being equal to 2, or sec x being equal to negative a third. Since sec is 1 over cos, you'll have cos x, the reciprocal of 2 is a half, or cos x is -3, which can't happen. So we only concentrate on cos x is equal to a half because cos can't exceed -1 below or above +1. So we concentrate on cos x being a half and x being the cos inverse of a half. This is positive a half, and between 0 and 180 degrees in the first two quadrants, cos is only positive in the first quadrant, which gives us 60 degrees. So the answer for this question, the value of x is only 60 degrees. So there are many other questions which we can meet, and each of them will be having its own approach. But I believe that in any question you will meet through practice, you'll be able to recall what we have covered in the topic before and apply it so that you can get the correct answer for the given question. Thank you for following. Don't forget to subscribe to our channel so that you can support this content as it keeps streaming in.